To begin this tutorial, the first thing we need to do is add the reference image. To do that, we simply drag the image into the viewport, press OK, and set the center to 0 so we can manage the size more easily. As we can see, the limits of the image align nicely with the curves, so I can type 30 to set the width to 30 millimeters, press Enter, and then type 60 for the height. In fact, we could just type 30 and press Enter, and the image would already be created correctly. Once the image is placed, we select it and type Artisan Center. Then press Enter in the command bar to position it properly. Now we have our reference image. It's important to clarify that this is only a reference image. We'll use it to guide the style of the model, but we're not going to reproduce it exactly. I'll move this image to a separate layer and lock it, so we can work freely without it interfering with the modeling process. The first thing we'll do is create the solid structure. For that, we go to the Curve tab and use the Curve command. I'll start by creating this inner section first. Once the curve is created, we can adjust the control points to better match the proportions of the reference image. At this point, it's important to mention that we'll be adding gemstones to this solid and creating rails. So, for example, if this side is represented by this line, we need at least 0.4 millimeters of metal thickness to keep the design structurally safe. Then we'll add a 1.30 millimeter gemstone, and after that, we'll need another 0.4 millimeters of metal on the other side. That means the minimum distance for this rail needs to be 2.10 millimeters in order to accommodate the metal margin on both sides plus the gemstone. Keeping this in mind, I'll leave this curve here as a reference. This curve should have an offset of at least 2.10 millimeters. After that, we can create an inner offset of 0.4 millimeters and another 0.4 millimeters on the opposite side. This way, the rail will sit here, and this will be the metal structure. Once we have this, what I personally like to do is create reference lines. This helps Rhino understand where to place the geometry when we use the network command to generate the surface. By doing this, we're helping Rhino identify the seams we need. So now I can run the network command and select the outer curves along with the inner reference lines. This allows us to see how the surface follows the intended flow. I'll switch the display mode to shaded so we can see it more clearly. Now I will type Cell Curve to select all the curves and move them to another layer. As we can see, we already have our first surface. We'll repeat the same process for the rest of the design. Using the Curve command again, I'll turn off Grid Snap and create the next curve of the model. It's worth mentioning that the fewer control points we use, the smoother the curve will be. We can always refine it later. We'll create an offset of 0.4 millimeters, then an offset of 2.10 millimeters, and finally another 0.4 millimeters on the other side. Here we can see that the curve is a bit short, but that's not a problem. We can follow the same pattern and create the offset of 0.4 millimeters here as well. We need to make sure this point is selected, then use Move to align it correctly. So that later, we can join everything using the Join command. We'll do the same with the other curve. Once both are aligned, we join them. To make the result smoother, we can delete any unnecessary curves or extra control points. We'll do the same cleanup on the opposite side. At this point, if we wanted, we could add another curve here. But since I'm going to place a gemstone here and add either a basket or a bezel, that won't be necessary. We repeat the same procedure as before, adding reference lines to help the network command generate a clean topology. It's especially important to help Rhino in more critical areas, like these tight curves. Once again, we use network, selecting the outer curves and the inner reference lines. Perfect. Now we have our second surface. I'll do the same process for this section and this one, and I'll show you the result in the next step. I'll speed it up a bit, since the procedure is exactly the same. Once all the curves are ready, we repeat the same workflow. There are many ways to build this model. We could use profiles, lofts, or networks. Each person should find the method that best fits their workflow. If the surface appears inverted, like in this case, we can simply apply a flip to fix it. Even so, if we check the topology and notice it's not correct, it usually means we're missing a reference line. So we redo it, add the missing line, and generate the surface again. Now, I'll hide the curves and select this layer to create another reference curve. This time, I'll use Extract ISO Curve. We can see it's extracted in a direction we don't want, so we go to the command bar and switch it to V. Using Snap, we select the midpoint. We'll repeat this process for all the surfaces, so we end up with the curves we need to position the gemstones. Now that we have the curves, we can decide how to proceed. We can create one side first and then join it with the other. I'll use Cell Surface. And from the perspective view, I'll extrude it by -1.8 millimeters. I'll switch everything to shaded, and now we can see that we already have a solid. However, we can see that this part doesn't reach the center. To fix this, I'll select the polysurfaces, go to the Transform tab, and use Mirror. From 0, I'll hold Shift and click at the top. Now we have the other half. Since we still have the curves, we can mirror them as well. I type Mirror, enter 0, press Enter, and hold Shift to make sure it stays aligned. Now I go to the Curve tab and use Blend. I blend this curve with this one, and Rhino generates the transition. I do the same on the lower part. Now I have both curves. With these, I go to Surface and create a loft, then extrude it by -1.8 millimeters to create the surface. If the extrusion appears inverted, type Flip in the command bar to orient it correctly. We can hide both halves, remove these two faces, then show everything again, and remove the overlapping faces so we can join cleanly. To select a face of a poly surface, we hold Ctrl plus Shift. Move it to the same layer as the rest. Now we're ready to position the gemstones. We can hide the curves we no longer need and start using the remaining ones. We'll begin with this section and continue placing the gems one by one. We use Gems on Curve. Assign this surface for orientation. And I'll use 1.30 millimeter gemstones. I'll edit this set slightly to reduce intersections and leave a margin. We copy the setup to the next curve and repeat the process. We do the same here, assigning the surface using 1.30 millimeters and leaving enough margin. For the last section, we extract another ISO curve. Join the two curves and create the gemstones, again using 1.30 millimeters. This one we'll keep centered. Now we can enable the prongs. Here we can see that these prongs are too small, so we ungroup them We delete the extra ones and adjust the outer prongs accordingly. For the dynamic prongs, we can reassign the surface and alternate between surfaces using the selector. We remove any unnecessary prongs and continue refining until everything looks correct. Next, we add the central gemstones. We check the orientation surface, set the size to 1.30 millimeters, leave a margin, and center them properly. We activate the prongs, review them, and finish this section in single mode. We ungroup and add dynamic prongs where needed, especially along curved areas. Once again, we remove any prongs we don't need and add one in the center if necessary, using Alt to copy it. Now we select the poly surfaces, move them to another layer, and hide them. We can delete temporary geometry and reorganize the layers. We select everything, apply mirror from 0 while holding Shift, and now the symmetry is complete. Some areas may be duplicated. But the rest is correct. We group everything and continue. At this point, I'll hide the reference image for clarity. Here, we can see that these two parts need to be cleaned up. Select the solid and perform a Boolean split. Then delete the excess. Now I'll hide this. Show the curves again. Now we'll move on to creating the rails where the gemstones will be placed. To do this, we need a margin of 0.4 millimeters on all edges. The lower part still needs to be defined. To continue and create the rails, we'll use push and pull. First, hide any curves that remain inside the rails so we can select the entire surface correctly. Then, activate push and pull. Select the area, right-click to confirm, and enter a value of 0.4 millimeters to create the rail. Repeat this process for all the rails. Remember to hide any curves that cross through the center of a rail, as they can prevent the push and pull command from affecting the entire surface. If Rhino selects too much geometry, it means the curve doesn't reach the end. In that case, we extend or move the control point slightly until it does. Once all rails are created, we mirror them from 0. If any section doesn't behave correctly, we can duplicate an edge, offset it by 0.4 millimeters, join the endpoints, and then perform the push again. At this point, the structure is almost finished, and we only need to add the remaining gemstones. From the top view, we create reference circles. We start from 0. Hold Shift to ensure they're centered. These circles are only references. Once they're placed, we can copy them using Alt, mirror them, and complete the layout. Now we go to the Diamonds tab and use Gems by Circle. If any gemstones appear flipped because the circles were mirrored, we simply select them and use Upside Down. Since the rails were created at -0.4 millimeters, we lower the gemstones by the same amount so everything aligns. Now everything fits perfectly. Select one of the gemstones, then go to the Diamonds tab and use the Bezel command. Without selecting any preset, click Edit. Set the width to 0.40 millimeters and reduce the height to 2 millimeters, making sure it does not rise above the rest of the elements. If you notice that even with these values the bezel still looks too tall, accept the command anyway. Then edit the gem and reduce its size to 0.16 carats. Accept, and click Update so the bezel adapts to the new gem size. In my case, I will delete the 2 gemstones that sit next to this bezel. Now we can use the Apply Style command to apply this bezel to the rest of the gemstones. Click the command, select the bezel, and then select all the gemstones where you want to apply it. If you are unsure, show the reference image and apply the bezel to every gemstone, except the ones that will be connected with a pear-shaped gem. At this point, we simply fine-tune both the bezels and the gems. If you want a smaller bezel somewhere, reduce the gem size first and then update the outliner so the bezel recalculates correctly. We can also reposition the bezel and the gem to fit the model better. If needed, edit the bezel and reduce the girdle width, for example to 0.58 millimeters. To simplify the process, you can fully refine one side and then mirror it, since the model is symmetrical. Adjust each bezel to your taste until the design feels balanced. Now that the bezels are in place, we'll refine a few details. For example, if one rail overlaps another, select both rails and, in the Solid tab, use the Boolean split command. Delete the part you don't need and repeat the same step on the other side. Next, for the upper gem, we'll create a basket. Run the basket command, go into Edit, and set the diameter to 1.70 millimeters. Accept the command, then adjust the height so it matches the rest of the model. Apply this basket to the rest of the gems and then edit them. Set the prong diameter to 1.30 millimeters and the height to 3.80 millimeters. Then, in the Rails section, set the width to 1.10 millimeters and reduce the prong diameter to 1.20 millimeters. Disable the upper rail and adjust the height to 2.30 millimeters. Now edit the lower rail and set the width to 1.10 millimeters and the height to 0.80 millimeters. If needed, you can refine the height further to 2 millimeters. You can also adjust the gem size percentage to 37%, or to your preference. Once everything looks correct, accept. I will delete the other baskets and apply this updated basket, since we are very close to the final result. Now we'll bring back the reference image. Go to the Diamond tab and use Gem Studio to create the last gemstones we need. In this case, the pear-shaped stones. Create one, position it, and then adjust its size. In my case, I'll leave it at 1.18. Then create the remaining pear gems. Next, select the central gemstone and apply a bezel. Accept it, but reduce the gem size slightly so it fits the model better. Reposition both the gem and the bezel. Then apply this last bezel to the other gems as well. Now we only need to refine the final details. You can reposition elements as you like, and you can even edit the basket and rotate the prongs if needed. The next step is adding a solid element that supports the central part of the model. To do that, we'll use the curve that crosses the design. Adjust its height from the right view, then use the pipe command, and adjust the diameter to your taste, using the bezel as a reference. We'll also take this moment to refine the bezels, setting the height to 2.10 millimeters. Repeat this for all bezels. We will also adjust the central solid so it integrates better with the model, or we can simply recreate the pipe with a diameter of 1 millimeter. Next, we'll create connecting curves between the lower part and the rest of the model, and generate additional connection pipes to reinforce and secure the earrings. We'll do this across all key areas to make sure every element is properly supported and connected. Once we are happy with the structure, we'll rotate everything 90 degrees so the earrings sit vertically. Go to the Curator panel, open Findings, and choose the earring post push of 9 millimeters. Position it at the top of the model, near the basket. Then edit the basket and, under Post Support, set it to double, so we get a stronger hold. Set both the width and the thickness to 1 millimeter. Finally, adjust the position of the post and push, and move it to the metals layer. Now the model is fully completed. Remember that the images are only references. The goal is to adapt each design to your own style and preferences, so take your time refining every detail you need. To prepare it for rendering, create the pear, position it, and generate a reference render. Feel free to share your result with us.